So good morning again. So I want us to first discuss this. So last week, I think, not Monday, I think it was last week, I gave you these questions and some of you have done both. I think Lillian and someone sent me the complete solution of 1 and 2. So I just want to be sure that we have done it. Please raise your hand if you have done 2. If you have done 2, raise your hand. Okay. Raise your hand if you haven't done 2. Either you don't have time or you don't just care about 2. Maybe you hate 2, being the only prime number that is even. Okay. All right. Okay, so 1 has been done by almost everybody. That's good. Okay, so raise your hand if you still have questions with how 1 is done. You're a bit confused, you're not sure, raise your hand. Everybody understand the shift expanded shift process? Yeah? Hello? Everybody understand the process? Okay, good. Please, I need response in real time. I don't want any form of drama today, please. So for maybe we do 2, one of these 2s together. Then others can then go back and attempt the others. It's just some random application of stuff. So can we choose one? Again, who are those people who raise their hand that they haven't done 2? Okay, just 3, 4, 1, 2, 3. And Nakita, are you also in the group? If you haven't done 2.
I haven't done 2.
Okay, so among those that haven't done 2, choose one of these questions. We have A, B, C. Choose one. Let's do it together as a class. You don't have a class, right?
No.
Okay, good.
How about C?
Speak up, sir.
How about C?
To C. Okay. All right. Those in favor of the motion say aye, aye. Those against it say nay. The ayes have it. Have you been in parliament before? I've seen it on TV. No. That's where they say that. Those in favor of the motion say aye. Yeah, aye. Those against it say nay. Maybe a few people say nay. And if you keep quiet, well, your motion is ruled against. And you hear the ayes have it. You know, when I was young, I thought the ayes have it means like our highs. I never knew it means A-Y-E, highs. Hi, hi, like yes. I thought they were talking about this. As a child, you don't know. You say the highs have it. Oh, maybe my highs have it. No, not your highs, Clarissa. So I don't think we're talking about your highs here. All right, so we'll start with C. And the question, which I believe you have, is show that x cubed. Nakita, could you give me the question C? I believe you have it in your notebook.
X cubed plus
Hold on.
8.
Show that x cubed,
Wait. X cubed plus 8x squared plus 24x plus 25 plus 25.
Oh, plus 25.
Yeah. Greater than 0 for all x greater than -2.
For all x greater than -2.
Yes.
So we want to show that this polynomial is always positive for all x greater than -2. You see, so that's an interesting question, isn't it? And thanks to that shift, expand, shift process, we can do it easily. There might be other ways, like basically it's about factorization. If you're able to factorize, and then you can maybe prove something. So I'm not going to go into why what we are going to do. Okay, in the shift, expand, shift process, any polynomial p of x, if it is in cubic form, can be expressed in the powers of x plus k. So for example, a x plus k or minus, depending on what you want to achieve. Then maybe b x plus or minus k squared. Then maybe c x plus or minus k. So then plus d. So this is cubic, right? This is quadratic, linear, and the constant. So you must have all these terms. So any polynomial p that is in cubic polynomial can be expressed in that form. And if it is polynomial of degree 4, you have 4, 3, 2, then you're going to have d of x plus or minus k, 1, then plus e, something like that. Okay, so rather than expand, collect like terms, find the value of a, b, c, d, then there was this shift, expand, shift method, okay, process that has been investigated, verified, it works, and that's what we're going to use. In that process, from what you have read, from what I sent to you last time, if you wish to express something in terms of x plus k, okay, let me start with this. If I wish to express a polynomial f of p of x in terms of x plus k, so which means I want the final result in terms of x plus k, I'll define a new polynomial. This is shift. Now, this shift should be okay to us now because we have done, remember this, in quartic polynomial or even in cubic polynomial, any polynomial x plus maybe 1 to power 4, what does it do? What is the transformation from this to this? Do you remember? Unmute everybody, unmute, unmute, unmute. Where's that manage participants? Yeah, unmute all, okay. If your background is noisy, then fine. If your background is not noisy, just keep it there. Nakita, I think you mute yourself again. Anyway, do you remember the transformation from here to here? In one of the quartic polynomial investigation, we had this. Brandy, quickly. Do you remember?
Not really.
Not really? Mr. Cheng, I need your attention here.
Yeah, I'm just trying to see on this motion.
Trying to check. Cheat.
Oh. Okay.
Cheat. Okay, everyone look at my screen. Let's just recall this. So this is graph of x to the power 4. Now let's see the graph of x plus 1 to the power 4. Can you see that? Let's see the graph of x minus 3 to the power 4. Can you see? So if I take this off, can you see the transformation? So there's a shift. So it was, I think, question 1. Either 1A or 2A or 3A, I can't remember. Like the first question, I asked you the transformation between this and this. And most of you wrote, it's been translated by a vector B0, something like that. Do you remember that investigation? So you can always think of it that way. So if I have, Foodie is eating again without sharing. So this definitely, from here to here, there's a shift. Okay. This plus 1 shows that you are shifting 1 to the left because the plus goes to the left, the minus goes to the right. If you look at that decimals up again, let's look at that decimals up again. Can you see? This green is minus. So basically it's x minus b. That b is the shift to the right. If b happens to be negative, then it shifts to the left. That's when you have x plus b. Look at the case of plus. If this was plus 5, see what happens. So it comes 5 units towards the left because the general form is x minus b. That b is the shift towards the right. So if b happens to be negative, then it goes towards the left. That's when you have plus in between. Okay. So what am I trying to say in essence is From here to here, this function will be deduced from this function by a translation of 1 unit towards the left. That's what I'm trying to say, okay? And that's why the process is called shift. So you shift, you expand, then you shift. Because in the process, the first step, if you want to express P as a polynomial in terms of x plus k, right? The process is to shift it as with x minus k and expand. Basically, define a new polynomial that transforms P by shifting k unit to the left. Then, after you expand it, you collect the like term, then the original polynomial you're looking for is when you shift it back. This is what you want, but you have to do the opposite first, then you go back to what you want. Okay, that's why it is called shift, expand, shift. You shift it first, you expand to get a very nice, good-looking polynomial. Then you shift that polynomial again, and you have what you need. It's still the same polynomial, okay? You shift, you expand, you shift. All right, so in this case now, we want to be able to get this polynomial to be greater than 0 whenever x is greater than minus 2, right? Which means we are interested in eventually x minus 2, something like this. Such that if we can prove that this is positive, of course, this is positive only when x is greater than this, right? Because a minus b is only positive if a is greater than b. And this is trivial. If a minus b is greater than 0, when you take this to the other side, it means a must be greater than b. Am I making sense, please? I need attention and I need response in real time. So we can only prove that this is this if x plus 2 is greater than 0, right? Which means we are interested in having it as powers of polynomials in terms in powers of x plus 2. We're interested in expressing this as polynomial in powers of x plus 2. So our shifting will begin with expressing as x minus 2, expanding, then putting it in the original form that we actually need. Am I making sense? Okay, so basically, I would say that to show this, it suffices, or we first, so write proof. Okay, we must, now before then, I would say, because the polynomial must be some P or Q, we need to give it a name, right? An identity. So let's P of x be the polynomial x cubed plus 8x squared plus 24x plus 25. That's a polynomial. You don't put this. So most of you are not looking at the board. So when I circle something, I say you don't put this, you don't even know what I'm talking about, because you are not paying attention when I circle that part for you to actually know what I'm talking about. So this is the polynomial. So we defined it. So what we are trying to do is we now express P of x as polynomials, sorry, in the power of x plus 2. Okay? And to do that, we first of all, we define a new polynomial, Q of x, which is when we shift with this. Am I making sense? So the first step will be that. Then we expand and get Q. Now Q is the polynomial we get when we shift P 2 units right. So take, for example, the polynomial P is here. When you shift it 2 units right, you get polynomial Q. Then we come back and shift Q 2 units left, we get our polynomial P back. That's the idea. Okay, so we're still on the same spot. This is your polynomial P. Okay, you shift it 2 units right, we call it polynomial Q. So you have changed the polynomial, but that's not what we need. Then you do the shifting again, backward, 2 units left, then you get your polynomial. Because you really want to have this, but we can't do it directly. So you have to get this and come back like this. All right, that's what the process is about. So if Q is this, then it means that our polynomial Q of X is actually, now if this is P of X, then P of X minus 2 will be X minus 2 cubed, 8X minus 2 squared, 24X minus 2, and 25. All right? So then we simplify this. We have done binomial expansion. So remember, to expand power 3, it is 1331. Or should I, so which means the first coefficient, we have x cubed, right? Then 3x squared. So basically, a plus b cubed is a cubed, 3a squared b, 3ab squared plus b cubed. I hope you remember this. Do you still remember this? So I'm going to use this. So my a is x, my b is minus 2. So a squared b will be x squared negative 2. 3ab squared is x negative 2 squared, then plus negative 2 cubed. Does that make sense? Then I'm going to add 8 brackets x squared minus 4x plus 4. Then we open the linear, 24x minus 48, then plus 25. So I'm going to arrange this. So x cubed, this will be what? Minus 6x squared. I need contribution, please. This will be 12x, and this is minus 8, right? When you open this bracket, this is plus 8, so maybe we can get rid of this one. 8x squared, so I can put that under x squared. 8 times 4 is 32, we put that under x. Then 8 times 4 plus 32. Then we have 24x, so we put that here. Then minus 48. And the last is plus 25. Okay, then we can add everything together. Okay, so I just draw a line there, then I write the answer on the next. Okay, so this is like the addition of all the terms. I don't have enough space. Make sure you write it under that space. So with this, it implies that our polynomial Q of X is actually what? Okay, tell me. Q of X is what?
Power 3.
You have to speak up, please.
X to the power of 3 plus 2x squared plus 44x.
Say that again.
44x.
I don't think so.
Wait, no. 4x.
What?
It should be 4x.
4x. Is that true? And
Yeah.
finally, waiting.
1.
Confirm, please. Is that right? Let's check. Okay, so that's our Q of X. So we have done the first step, which is shift. Second step, expand. The third step is shift again. Okay, so our polynomial P of X will now be when we shift this back. Remember, we shifted 2 points forward here. So we shifted 2 points backward. So that's plus 2. Okay. So which means our polynomial p of x is, so q of x plus 2 from q of x will be 2x plus 2 cube, then 2 brackets x plus 2 squared, then 4x plus 2 plus 1. Does this make sense? Response, please.
Yes.
So why do we need this? Because it is easier to actually see that when x is greater than minus 2, now when x is greater than minus 2, okay, when x is greater than minus 2, it means x plus 2 is greater than 0. Do you agree?
Yeah.
Yes.
So that's the whole idea. So if x plus 2 is greater than 0, it means that this term is greater than 0 because this is a positive number. Cube, that's positive. Square it, that's positive. Square this, that's positive. This one positive. So, and none of this is negative. So if each term is positive and you add them together, it means everything is still positive. Does that make sense? So that's the whole idea. Clarissa, I'm not getting any response from you. Does that make sense?
Yeah.
All right. So that's the whole idea. You want to prove something is positive for x greater than a number, bring it to the other side. It means when x minus that number is greater than 0. So you express the polynomial as power of that x minus or maybe x plus. And luckily enough, you should have that all the coefficients are positive. If all the coefficients are positive, including constants, the powers of positive number is always positive. There are positive coefficients, then trivially, the whole polynomial is positive. That's the only reason for doing that. Okay, so this is how we conclude. So we say, since x is greater than minus 2, that's the condition given from the beginning, implies that x plus 2 is greater than 0. It means that each term of the polynomial is positive. Okay, including the constant is also positive. So therefore, the entire polynomial p of x is greater than 0 for all x greater than minus 2. That's all. And that proves the question. Okay, so this is from last time. Okay, so we move on. So you see, this is not like a topic on its own. It's not like a logarithm. It's not like, it's just a process of transformation of functions. And it's clearer now because you have seen a lot of transformation from your investigations in graph. And now that you're dealing with polynomials, what if inequality comes in? Then you have to be able to think about this stuff. Oh, okay, maybe I can apply this, or maybe I should apply that. All right? So that's that about that. So with this, I expect you to be able to do the 2 on your own. We'll not waste our time on that now. So we go to the next set of things that we need to do. Okay, So we're doing products of roots, sum and product of roots. No, zeros and roots. Okay, zeros and root the last time. So we're going to, let's start today with this as exercise. So I want you to do question 9. I'm going to leave the zero and the fraction so you can do that practice on your own. Let's deal with 9C, then G and H and 10. 9C, 9G, 9H, and 10. I put it in the WeChat group also. 9C, 9G, 9H, and 10. Okay. Those 4 questions, you have 10 minutes, please. Maximum 10 minutes. I'll send a picture also to the WeChat group. I'll send you this in case anybody needs some guidance. So you can check your WeChat group in case I take it off the board. When you are done, I will also assign some questions from 11 to 14. The question is also on WeChat group. So I want to see the 9 stuff first. So WeChat me your solution individually. Keep sending in your solution. I'll check as soon as I'm done with this. So let's see 9E. So we have 1 plus or minus 3i. All right? Yes. So the question says, find all real quadratic functions with zeros that. Okay, they are functions. They are not equations. They are just expressions. You were here the last time when I did x squared minus alpha plus beta x, right? Plus alpha beta equals 0. Were you here when I did that?
Yes.
So you remember how I got this? I got it from expanding. Yeah, remember this? So if these are the zeros of the function, it means the factors are x minus alpha, x minus beta being multiplied, and we're able to simplify it to get this. But because it's a function, there's no need to put it equal to 0. It's not an equation. And this, I said, simply means sum of the zeros, not root this time, then product of the zero. Because if alpha and beta are the zeros, then you have this. Understood? So that's what we're going to be doing. So your focus is to look at the sum of the zeros. That's 1 plus 3i added to 1 minus 3i. Understood? And that gives 2. The product of the zeros, the product of these conjugates, these complex conjugates, which gives 1 squared, 3i squared. And that is 1 minus negative 9. Remember, this is I squared, right? So, which would be 10. So definitely, you have the function is x squared, right? Minus sum. What is sum? 2x plus product 10, right? But there's something I want everybody to pay attention to. The question says find all functions. You put here bracket a, where a is not equal to 0. Does anybody know why?
Because if it was 0, then the entire thing would be 0, and it wouldn't look the same.
Okay, that's why, that is the reason for this. Why do we need this a? Why can't it just be x squared minus 2x plus 10 only?
Because that's not all the functions with those zeros.
What do you mean?
Like, because if it's just that, then it's just going to be like this. But with a, it can get wider or like, smaller. But like you'll still have those zeros.
Exactly. You did hear what he said? Because remember, if it intersects at these 2 points, for example, of course, this is complex. Let's say these are the point of intersection. You can have this, right? You can also have the one that is so wide like this, right? You can have different shapes passing through the same point, and that depends on the value of a. Okay, so that a is very important. We always include that. Now, if this was an equation, check this out. If this was an equation, look at this family of equations. X squared minus 9 is equal to 0. Yeah. If you solve it, you get x plus 3, x minus 3 is equal to 0, and you get x is equal to minus 3 and 3, right? If you have 4x squared minus 36 is equal to 0, this is what you still get. And here, this is actually 4x squared minus 9, right? So this is the a. So even with your plus or minus 3, it's not peculiar to this one only. This is only the case of a is equal to 1. A could be any number, all right? So that is why after you find your sum and product, you put this in bracket. You put a outside that bracket, okay? So the function should be x, a bracket, x squared minus sum and plus product is a function, so there will be no equal to 0. And that's how we got that, where a is not equal to 0. Okay? Understood now?
Yes.
All right, off you go.
Thank
So,
you.
Lillian, did you notice what I said here about the a?
Yeah, I changed
So
it.
make sure you include that in your solution, all right? But every other thing looks fine. So well done. Okay, you don't need to resend it, just to correct, to add that information for you. Miss V, okay, she added the A. Yeah. You can use sum and product as well, remember. Vena, when you have like a third form, where is she? I need to see her face when I'm talking to her. Okay, there she is. when you have the SORD format, it's not advisable to use these brackets ones, okay? Can always use this when you have the SORD format because you can actually simplify this function. It doesn't have to be in factorized form, okay? You can actually simplify it. So if I wanted to do this, I would say, you give me the roots, okay? Of course, in factorized form, that's what you have, but we don't want it to look complicated. We can still accept this. So if you have maybe 3 plus or minus root 5, I don't know what that one is. Plus or minus root 2, okay, negative 3 plus or minus root 2, okay? So I would say sum, I just use S, of course you call it sum, minus 3 plus root 2, then plus minus 3 minus root 2. So the plus does not affect it, right? And that gives negative 6. Then the products, conjugates, right? They're conjugates. And the product of two conjugate SORD is always a rational number, right? So you get negative 3 squared by difference of 2 squared, then root 2 squared. That gives you 9 minus 2, which is 7. So the function you are talking about is x squared minus sum, which is plus 6, plus product plus 7, where a is not equal to 0. Okay? That's better than the factorized format you have. So well done. I just want to see you guys make some attempts, so it doesn't have to look perfect. Okay. All right, good job, good job, good job. So don't forget the Mr. Chang looking at your work now. Okay. You have it in factorized form. All right, see that. Ethan, can you put a is not equal to 0 as a condition, please?
Oh, yeah, okay.
Always include that. Very important. Thank you. Krista C, checking your work now. Okay, you did the sum. All right, root 2, then product. Yeah, that makes sense. That makes sense. Good job, good job, good job. Krista C, you can't have that because, okay. So x plus 7x minus 1 is not the same. X plus 7x minus 1 is not the same. No, it's not the same. So you have x squared, right? If you look at the board, please. And this happens to be from minus 3 plus root 2. These are the factors. So there is no way it will lead to another set of factors as claimed. There's no way. Because if you solve this, if this happens to be equal to 0, you're supposed to get negative 7 and 1, right? But that's not what the original thing is talking about. So there is no way you can have this and you end up getting factors that are, you get my point? So you should know that you have made some wrong assumption. And it's very easy to see. Plus 7 times minus 1 is negative 7. But this is plus 7. So these are not the right factors. So you just leave it in this form. You don't need to go extra mile and commit unnecessary blunder. All right? No need to do extra stuff. Okay, thank you. Just erase the last part. That bracket form is fine. And just include a is not 0. That's enough. Okay, well done. Checking Miss V's work now. All right, this is better now. You have the sum, the product. Okay, you call them alpha plus beta and alpha beta. Okay, that's fine. But then you need to, that means alpha and beta are the roots, right? There is no thing, there's nothing that says alpha and beta are the roots somewhere. So I would prefer you say sum of the zeros, unless you say alpha and beta are the zeros, something like that. But it's fine. I think it's actually not significant. I'm just being unnecessarily mathematical OCD. Just ignore me. Okay, question 10 for Lillian came in. Is that question 10? Yeah, okay. So it's the same technique. Yeah, good. Then you have that. Perfect. All right. So if you finish, Lillian, because you finished, I want to assign the following questions next. Oh, I think you already have it in your WeChat anyway. Maybe I check the WeChat. Look, it's slow to load. Okay, so Lillian, I want you to add 11F, 12A and F, 13 and 14. Okay. Of course, I will close the class. That will be regarded as homework. You submit on using the Microsoft Word format. I'll write that on the board now. So I will choose 11F, 12A and F. Okay, 7 and F, 13 and 14. Okay, 11F, 12A and F, 13 and 14. Okay, how about this? I won't set it as homework because I don't want you to have this pressure of, oh, you have homework to do. I've already promised to make life easier, quote and unquote, this week because of your EE deadline. Okay, so take it as practice. So if you are not to submit, then you can always decide when to do it and when not to do it, right? So I think I'd rather put it that way. Okay, so I don't want you to get pressurized unnecessarily. So question 11F, 12A and F, 13 and 14. Okay, you already have the picture sent to you. Yeah, thank you, Lillian. Thank you. 11F, 12A and F, 13 and 14. Yes, Lillian also sent it to the group. So practice those. If you happen to practice it, I have the solution also. So I can find the solution from the book and send it to you. You can compare with what you have and be able to see if you have, crossed every T and you have dot every I. Okay? So feel free to contact me if you are able to do it. If you also require some support in getting it done, so please also feel free to contact me. Even though we have holiday, I can probably just come online for 5 minutes to explain something to you if you want. Otherwise, we can always talk about this when we come back proper on Monday. Okay, everybody? The firewall has been detected, blah, blah, blah. What is this? What's going on? Okay, Karen, everything good?
Yeah, yes.
No problem, everything good?
So far, yes.
So far, yes. Okay, Callista, everything good? Please note that for the ones you are going to be doing that involves cubic, so basically this is the int. If it is a cubic function, so, and you have 3 roots, right? So there will be a linear function, maybe x minus a, and there will be a quadratic. Okay, and of course, there will be some p in front of the brackets. You get my point? Okay, so please take note of this. Can everybody hear me? I wonder why I can't see you guys, but that's okay. I think There's something about my system is detecting some so-called firewall and it's probably blocking a lot of things at this time. Okay, anyway, I think I can see everybody now. Just making sure. Okay, so please take note. So basically, the quadratic that you have just done is this. That's why you either have 3 plus or minus 2 roots 3, something like that, or maybe 2 plus or minus I. So this is the quadratic because it's going to be complex conjugate, right? Or maybe short conjugate. That's quadratic. And the third one is the linear. So you don't have to expand this. Leave it in this form and put some A in front of the brackets, okay? Because it's a function we are dealing with, right? And for the roots that are 4, if you are given maybe alpha, beta, delta, and gamma, then you can write it. They are 4 linear. Then. Do you agree? They are 4 linear. And have x minus alpha, x minus beta, okay, x minus delta, x minus gamma, something like that. Okay, and if I have maybe 3 plus or minus 2i, and another set 3 plus or minus 5 root 2, then it means you can write it as 2 quadratic. Okay, so x squared maybe px plus q, the other one x squared maybe mx plus n, and everything we have some a where a is not equal to 0. Does that make sense? Is this ints okay for everybody? All right, Callista, any problem? Callista, is there a problem?
No.
Need to speak. I want to hear you. I want to hear everybody. Krista C, any issue? No? Mr. Chang? No? Lily. She changed her name to Lily. Lily. Okay. Mr. B, everything good so far? Understand
No
the int
problem.
sent also?
Yeah.
Okay, good. Clarissa? All good? All right. Benna, all good? Okay. Nakita, all good? All right, so please reach out to me if you require more support. All right, at this point, I wish you the best. Good luck with your extended essay drafts in your respected subject areas. And see you guys live and direct on Monday. Oh my God, I cannot wait to see you guys. Okay, bye. Have fun. Caring, school starts early in the morning. Don't sleep off this time. Okay,
Oh yeah, Mr. Daniel.
we are back to normal business. Yeah. What?
Can we have E sessions during the break?
Okay, don't worry, my wife won't kill me, but we can. We
Okay.
can. Just message me 24 hours ahead.
Oh yeah,
All right?
yeah. I'll
Message you 24 hours ahead. In case we have some maybe doctor appointment, then I can always, change, something like that. All right. Because a dentist was messaging me today. Can you come today? I'm like, dude, you should have told me earlier. I'm not that I do, So just message me earlier. Things can come up. All right. Good luck, guys.
Oh, yeah.
See you.
Thank you. Bye.
How do I end the meeting now? Oh my God. Okay.